So in reading the preparation for this section by John Lennox, there's an emphasis on information. And so that's what my presentation is going to have as a theme throughout. So here is the overall progression. And I have to confess that by putting in more emphasis on information, there's not going to be so much emphasis on death and suffering. So if you like death and suffering, you're going to have to get it from somewhere else. Apologize for that. I'm going to begin with looking at two creation stories. Firstly, Genesis and then science, and that some of that's going to be very familiar to you. I'm going to spend most of my time in this second part looking at life's early building blocks. And I'm going to do that by looking at the Soal reaction in particular. That brings out this emphasis on information, where information came from, and that leads into where is God in nature. So a little over halfway through, somewhere in this point here, we're going to take about 5 minutes, I believe, and everybody is going to have time to discuss a question that I'm going to pose to you. I think you're going to be broken out in randomized groups, and then you'll be brought back. I'm simply going to start back up again at that point, and we'll take questions at the end and the conclusion. In the beginning, God created the heavens and the earth, probably the greatest lines that have ever been written. And these lines really state that it is God who is the source of everything. And all of the Bible from that point onwards are really about God's interaction in the world. In the first 3 chapters of Genesis, what we have is the opening of how creation is formed. And it's a unique blend of prose and poetry. It's often thought as a hymn, and it uses figurative language describing God and his activity, using human counterparts for that. On the first day, God makes light, and then 3 days later, he makes the heavenly lights. And they're called heavenly lights. They aren't called the sun and the moon because sun and moon were names for deities. And we just heard that in the beginning, God created the heavens and the earth, not other deities. And so it's this emphasis throughout that makes this strong connection that it is God who is in control. On the second day, God makes sea and sky, and 3 days later, he makes birds and fish to populate the sea and the sky, that the water teem with living creatures. And then on the third day, God says, let the land produce vegetation. And 3 days later, living creatures and people. So what we have here is a very specific pattern. Again, it goes back to this idea of prose and poetry. So on these 3 days, we really have forming. We have light, we have sea and sky, and we have vegetation. So this is all about forming. And then this section is all about filling the world with the different components. And part of the point of this is that there is this underlying order that shows planning, design, and intellect. And the result is an integrated structure that is infused with God's mind, with information presented throughout. Well, science also has a creation story, and the story is one that we know well. We've just heard many parts of it in Boris's talk, and that story begins 13.7 billion years ago with the Big Bang, and then about 4.5 years ago with the formation of the Earth, followed by the Hadean era, where the Earth was pummeled with asteroids and comets, and these brought, among other things, probably a lot of ice on the back of these asteroids that eventually led to the formation of a small pond and a biological soup, as Darwin proposed several years ago. And this biological soup ended up giving the small biomolecules of life, and that ended up firstly to the formation of life in the aquatic realm and then into the terrestrial realm, and ultimately ended up with the development of humans. So for some, and this goes back to Carl Sagan, he said the universe is all there is, all there was, and all there ever will be. And many scientists kind of operate from this perspective. There are a lot of assumptions in here, that articles of faith actually, and that is that the world was just there in the beginning somehow. And that's an article of faith, and it turns out to be a fairly fruitful position if you're a scientist. You can make that assumption. You don't have to, but it certainly allows you a starting point to begin. Many religious people solve this conundrum by saying that it was God that started the Big Bang to explain the origin of the universe and everything. But the problem here is that we as scientists operate within science. And as scientists, we have a belief system that we bring to our work. And that's because we are humans and we have an influence on what we do and how we interpret the world and the science that we perform in that world. So that's where the dichotomy starts to come, because we are scientists who are human, who work in science in the physical realm. So the framework that I'm going to use looks at this origin of the universe from the time of the Big Bang, and somehow these are formed in God's hands and at the cross. And it's really the formation of the world as a drama to provide a backdrop for the cross that really leads us to the most important thing that we should be focusing on. So I'm going to use this framework that science and religion are fully compatible. And sometimes there are disconnects, but these disconnects exist because of our understanding. They're not somehow a dichotomy between God and science. There's no disconnect. There's no place where we can go and see, well, God did it here. There's no tags, no proof that says this universe was made by God. So now I'm going to spend most of my time, after just kind of setting up those early pieces about how the origins started, to look a lot at amino acid synthesis. And Boris mentioned this with the Milli-Urey experiment. And so what was this experiment? Well, this experiment took what has been considered as the early atmosphere of early Earth that had a number of gases: methane, ethane, ammonia, nitrogen, water vapor, hydrogen, carbon monoxide, carbon dioxide, hydrogen sulfide. And it places them in this sealed apparatus. It's a rather kind of simple setup. And it has a couple of features about it that are particularly interesting. So up here we have two electrodes, and those electrodes were tungsten electrodes that had a spark discharge. Now you could say, well, that spark discharge is kind of like the lightning that might have been present in the early Earth. And even though lightning turns out to be not such a great way of putting energy in, as Boris said, you do need to put energy into the system to make it work and get it going. So these gases are percolating around, and they have this discharge, and this discharge brings these gases together, and it makes amino acids. It makes a small amount of amino acids, about 2%. So we're not talking about a lot of material here. And these amino acids are collected, and they're collected, excuse me, they're collected in this receiving flask that serves to boil and provide vapor for this process. Now, the Earth at this stage was probably not at 100 degrees C, but this was just a way to provide a capture of these amino acids and to be able to remove them from the system. So this gave about 2% of the mass that were amino acids. And these experiments have been repeated many times, and they give small amounts of amino acids. The main amino acid is actually this one up here, which is glycine. There are smaller amounts, much smaller amounts of the other proteins, and I've only shown 9 of these amino acids. There are 20 in total that are considered the essential amino acids for protein synthesis. Hotter temperatures would have been better for providing the energy for this system, but hotter temperatures also have the problem that you have to consider degradation rate. So there's kind of a flux here. There's the formation as one rate, and there's the degradation as another rate. My expertise is in stereochemistry, and that refers to the three-dimensional shape of these molecules. And when the amino acids are made, they have this unusual property called chirality. Now, what is chirality? Well, chirality is like your hands. Your hands are mirror images of each other. So as I hold them up, you could imagine a mirror between them that would map one to another. And we know this when we're fumbling in our pockets for our gloves in wintertime, when we go to pull on our left glove on our right hand and it just doesn't fit. So in the same way as we have this chirality in our bodies, the amino acids that are made also have chirality, and that's apparent because carbon has 4 bonds and they point in 4 different directions in space, in kind of the same way that the palm of our hand and our digits also point in different orientations in space. So we have kind of what you might think of as lefties with amino acids and righties with amino acids. One of the issues with these spark discharge experiments is that they give rise to an equal population of lefties and righties. But the amino acids that then go to form into proteins are all only one hand. So in that sense, all of these amino acids over here that we then know are present in proteins are present in very specific sequences, but they're also a mix of only one of these hands, all lefties in a sense. And that sequence and having them all with the right chirality leads them to form functional proteins. And the functional proteins usually have an active site within them at which these amino acids code for a very specific orientation in their 3-dimensional space, but also the nature of those amino acids at the active site. So for example, sickle cell disease, which is an inherited blood disorder, this has at its origin a single point mutation of the amino acid valine for glutamic acid at the active site. And if you have this at the active site, you get sickle cell disease. So randomly incorporating amino acids into a mixture is not likely to lead to a functional protein. Let me give you kind of an analogy for this. Imagine that you are building a Lego house. So here is the Lego house, and imagine that you have a pile of bricks in order to make these, and these bricks are 20 different colors like the amino acids. And imagine you have 100 bricks that you're going to put together to make your Lego house. So this would be like taking 100 amino acids that could all exist as 20 different types and putting them in the same order. So the house probability of making a house like this would be the probability of 20 amino acids, each having 100 amino acids in sequence, each having 20 different possibilities. This is 20 to the power of 100. This is an amazing number. The chance of randomly assembling a functional protein like this would be roughly the same as finding one functional protein, one grain of sand in the desert the many times the size of the Sahara. So there's a sorting process that is involved in most of these reactions that generate these mixtures, these two chiral flavors, as I've been talking about it. So when we think about these Miller-Urey experiments, there's an intervention of information that is present in this. And one part of the information is present because of the experimental design, and the other part of the component is because of what you're collecting, what is interesting. And for that, it's these amino acids with these two hands. So you have to imagine sorting through these to generate just the right amino acid and just the right source. There has to be some natural process from a materialistic perspective by sorting out this information and then amplifying this chiral information. And that's what I'd like to turn to next. And this is the Soal reaction. It is a remarkable reaction because it amplifies very small chiral influences. And so this is a reaction of an aldehyde with diisopropyl zinc. Now, you're not going to find diisopropyl zinc lying around in prebiotic earth. This is a very reactive molecule. And it can react with the aldehyde, and it can react, think of this as reacting from the top of this molecule or the bottom of this molecule. And that gives these two chiral molecules as products. You can think of these as the two hands again. Now, when we as chemists work up this reaction, we actually treat it with water and we get this mixture out with these two compounds. And when we do this, we get equal amounts of these two compounds out. But the interesting thing with this reaction is that if you imagine seeding this reaction by taking one of these hands that you've previously made, and here I've represented it again over here, and you add it into the reaction mixture, that catalyzes the reaction to make more of one of these hands. So if you put in a very small amount of one of these precursors to start with, now you get a very high imbalance of these two molecules to begin with. And the amount that you put in as a chiral influence is exquisitely small. I went to a lecture several years ago, and it was about sending one of the NASA probes to one of the moons around Jupiter called Titan. And they were going to scoop up some Earth and put it in this reaction mixture and run the reaction, because if there's just a very, very small amount of the material there, it can be amplified to generate chirality that can be detected. So there's been about 2 decades of work on this particular reaction, the Soal reaction, in order to understand how the reaction works. It is exquisitely selective to initial chiral imbalances. It's so exquisitely selective that when stars are formed, they give off a lot of light, and some of that light is circularly polarized light. You can think of it like when you put on your Polaroid sunglasses, and this light has chirality to it, and that chirality is enough to cause this imbalance in the Soal reaction. The Soal reaction is also autocatalytic, meaning once you get a small amount of one of these products as an imbalance, it catalyzes the formation of more of that. So in a sense, we can think of this as symmetry breaking. This process of symmetry breaking is, it can come from crystallization in solutions. And you can think of this as when you form crystals, if they have chirality, a left and a right form, that it might form slightly more of one than the other. You can think of this kind of like your high school that you went to. If you look at your high school, roughly there's equal numbers of men and women who went to the high school. But if you look at very small schools, it's likely that you're going to get a balance that isn't 50-50, it might be 60-40, just because you're dealing with small numbers. So in a school of 100, you might well have 60 women and and only 40 men. So this kind of imbalance can give rise to a crystal form which can have chirality, which could be picked up in this reaction, and it could be amplified in this way, like the Soal reaction. So what I'm suggesting here is that here we're talking about a mechanism which the first chiral building block might have been formed. And the question is kind of, how does this work? And the way that it works has been found relatively recently, is that these building blocks, as I've been showing them, are actually formed as tetrameric structures like this. And these tetramers can form in a variety of different ways. They can be all of the same, and they can be all of the same with one chirality that I've shown as red, or they can be all of the same as another chirality that I've shown in black. And there are many other combinations in between, combinations of 2s with 2s and combinations of 1s with 3s, and red and black with red. And the point with this is that they're only active if they're either all red or all black, or lefties or all righties in one sense. And so what happens here is that these combinations, these tetramers that form, dictate the chirality of the product that you get out. And I just want to go through this with a couple of these graphs. And these graphs are showing on the left-hand side there, this is the percentage of unreacted starting materials. That's the percentage of this unreacted aldehyde in this diisopropyl zinc. And this is time on the x-axis here. So I want to start up here in this process where diisopropyl zinc is added with none of this extra chiral influence here. And you can see that for some time, the reaction doesn't do very much. There's an induction period where the reaction is getting organized. And then once it gets organized, this thing takes off like a Mercedes. It is just one beautiful reaction, and it goes extremely fast till about 60% of the starting materials are consumed, and then it's only slowed by, using the Mercedes analogy, it's only really slowed by the amount of gas in the tank, and it's starting to sputter here and then go down to 0. Now, in contrast, if we follow this dotted line down here, this is the second process where we add 20% of a 2-to-1 mixture of these two products. So we're seeding this reaction with a 2-to-1 mixture favoring the red lefty in this process. And you can see this reaction is it's extremely fast, and it goes extremely fast until almost all the material is consumed, and then basically it stops. And even though we put in a 2-to-1 ratio of the lefty to the righty, this came out with a 90-10 ratio of product. So this was extremely good at giving an amplification of the chirality in this reaction. And if you put in only 8% of a 99-to-1 mixture to seed this reaction, you end up with a 99-to-1 mixture coming out. Now, this is really important because there are two scenarios by which this type of mechanism might be responsible for being amplified into the kind of chirality that we see in biomolecules. So it might be that the same mechanism that's involved in this case is involved in the mechanism for actually making the amino acids. And here I show all of these amino acids. And I want to hone in particularly on this amino acid, which is known as proline. Proline is the only cyclic amino acid. Here it is again. It's also comes in one of these flavors of having a very specific chirality in its structure. And over the last 2 decades, there have been a lot of chemistry that's been done with proline reacting with carbonyl compounds. And carbonyl compounds are also what are posited to be precursors in life's early origin. And what's been shown is that if you take proline and essentially if you put it in water with these carbonyl compounds through a sequence of reactions and intermediate steps, which I don't have time to go into, that would will take us quite a while, but just let me focus in on this one structure here where we see a specific set of pre-organization of this carbonyl compound with proline that ends up causing a condensation, and then water hydrolyzes this off again to give this molecule with a hydroxy group and a ketone. And these are really the precursors to go and make sugars. So this might be a way that early sugars were made. So I'm suggesting that one mechanism could be the same kind of mechanism that the Soal reaction makes chiral molecules. There could be a way that this makes chiral molecules like amino acids, or it could be that there's really only one way to make these chiral amino acids, and that once they're formed, these chiral amino acids then go to form other chiral molecules. And this is important because this would be a mechanism by which chiral proteins would then go to form chiral three-dimensional structures that then serve as the early hardware in order to make other molecules, or it could be the same mechanism by which the information that is present in DNA goes to make the coding that's necessary for life. So the Soal reaction itself isn't a demonstration of life, but what it is it's a way of thinking about how this chiral information might have been present. So what I want to go to now is to look at where God is in this process. And in general, people have had kind of two extremes for where God is in the process. He can either be a deist and getting the universe going and then standing back and looking at everything rolling out from that point onwards, or otherwise he could be involved in every minute detail of creation. But in both contexts, God is the information giver, in some sense providing us with the blueprints for life, to understand how the world came to be. So I want to move to talk about specified complexity. Specified complexity is a way of capturing the information content in the world. So something like quartz is specified in the sense that the molecules pack it into a crystal in very specific orientations, but there's minimum complexity to that. Something like DNA has both complexity and specificity. It's specified in terms of its backbone, and it's complex in terms of the information that is coded in the very specific nucleotides that are present in the backbone. In the Soal reaction, it is more on the side of the specified complexity like quartz. It has some molecular interactions that cause the aggregation, but it's really a mechanism for generating this chiral information that comes in the beginning. But then the question behind that is where does that information come from? So part of what I wanted to happen in the discussion was the people that see that there are these two extreme views by which Christians view God's interaction in nature, either as a deist starting everything from the Big Bang and then sitting back in the armchair to see how it goes, or involved in synthesizing every minute detail. So stars that are 13.7 billion years old, synthesizing every single minute detail in there. So in both contexts, the point here is that God somehow is the information giver that lies behind there. And there are different kinds of information. And that's what I was pointing out with the specified complexity. So in things like quartz, then what we have is molecules that stack very specifically on top of each other. And in that sense, they have specificity, but they don't have complexity. Whereas DNA has both specificity and complexity. And the reaction that I've talked about has largely the specificity, and that comes about because of these tetramers that are formed, but it has much less in terms of the complexity. There is some, and that is amplified in this process. So we're looking at evolution, where we go from these tiny building blocks of life, amino acids and nucleosides, all the way through to human beings. And the information here is coded in different ways. It's coded in the system itself in terms of the aggregation of these products. Now, macroevolution assumes that that information is manufactured in living organisms through mutations that give rise to changes with beneficial effects on the one hand, and those are captured with an increase in biological fitness, or they're edited out because they don't have that biological fitness. So evolution serves as both a randomizing source and as a sorting mechanism in that process. So what about the origin of this information? And Zachary said that, you know, this is kind of self-evident. Well, self-evident kind of to a point. If we think about as intelligent agents, we're able to see where information comes from and make inferences. In the search for extraterrestrial intelligence, the SETI project, they look for radio signals with very specific patterns that contain information that comes, in their interpretation, from extraterrestrial life. Now, for believers, we say that God is the source of that information. And what Lennox does in his book is he says that, you know, that information does not suggest, if we identify that with God, it does not suggest a God of the gaps kind of argument, because it's saying that at the root, we know there is information. We have scientific evidence for it. It's just whether we're identifying that it was there forever, kind of the same argument that comes from cosmology, or whether that information actually came from God. So we can rationally answer the question of where information comes from by saying that either it was always there, or information creates itself from nothing, or that God is the source of all of that information. As the Apostle Paul said many years ago, actually, for as I walked around and examined your philosophical idols, I even found an organization with the motto, to an unknown extraterrestrial. Therefore, what you worship as something unknown, I now proclaim to you. That's a paraphrase of Acts 17. In the interest of time, I'm going to skip to say, you know, where is God in nature? He could be there in the chance events that occur. This kind of thing occurs in the chance events that occur. For example, when fish fertilize thousands of eggs, but only 2 or 3 of those end up going to maturity. So chance does not mean random. Chance provides a way of shuffling potentialities, in Polkinghorne's words. And we see chance in biblical writings as well. You know, Peter, to pay the temple tax, goes and finds a coin in the fish's mouth. That was a chance event, but it was a chance event that was imbued with meaning, with practical and theological ends. So evolution also has this potential to explore these chance events. There is another kind of chance in the quantum realm. This could either be in chaos theory. In chaos theory, one of the examples is the butterfly effect, where a butterfly beating its wings over Japan has a domino effect on the molecules around it, which causes a change in the weather pattern, which ends up setting off a tornado on the other side of the world in New York. Or another kind of quantum event is imagining when there is some kind of indeterminacy that is triggered at the statistical level, where we can't predict exactly what the effect is, but a small amount of information might trigger a quantum state that could have a domino effect that occurs in the macro realm. Now, as Christians, where we find this is actually in prayer. This is the causal joint. This is the place where information meets physical presence, where God meets us as individuals. Now, do me a favor right there as you said that. Move your arm. Raise your arm, your right arm. How did you do that? Now, that was just pure thought. That was information. That information had a physical outcome. And prayer works a little bit like this. So in one sense, we have prayer going up to us, to God, and we have an answer and information coming back. And if you look closely, these two prayer waves are out of phase. And what happens when waves are out of phase is that they destruct. And sometimes when we pray, it's the same as God's will. And maybe this is after we've been praying for a while, now prayer has changed. And what happens when two prayers are in phase is that the amplitude increases. Now, for the purist physicists out there, I apologize. I couldn't get the frequency to stay the same. But the point is that when we are in phase with God's will, great things happen. And that is also an information at the center of those interactions. So we've looked very briefly at these creation stories. We've seen how information is inimical in these early biological precursors, and we've seen that kind of at the heart of a lot of that is the information content.